All right, in this video, we want to simplify this radical expression over here. Now, probably a couple of different ways to do it. You can probably try to rationalize instantly, but I prefer to do substitution for a question like this for two reasons. One, it's an extremely complex question. And two, we notice that we have 2 plus root 3, 2 plus root 3, 2 minus root 3, 2 minus root 3 in the same place. So substitution makes this extremely easy. So what I would do in this question, I would make like a equal to the square root of 2 plus root 3. And the reason why I'm going to do this is because now I can replace the bottom over here with root 2 plus a, and this will be very easy to rationalize. And most probably in these questions, to simplify, the steps are always to rationalize. So you want to pick the substitution. So it's very easy to rationalize. I'll make b equal to the square root of 2 minus root 3, which means this denominator over here is root 2 minus b. To simplify the numerators, I just have to get rid of the square roots over here. So if I move to the other side, comes a squared equals 2 plus root 3, and b squared equals 2 minus root 3. The tops are just a square and b square, and now we have a new equation that's much easier to rationalize. So let's rationalize this equation. I'm going to multiply the top and bottom over here by root 2 minus a and root 2 minus a. I assume you know how to rationalize normally. I'm not going to explain that in this video, because if you don't know how to rationalize, you should be learning that first and practicing that before coming to a question this complex. Okay, so let's rationalize it over here now. In the numerator, I'm just going to have a squared times root 2 minus a. And then in the denominator, if I rationalize this, root 2 times root 2 is just 2. Should probably do it quicker, but I'll just show all the steps. Minus root 2a plus root 2a minus a squared. And then over here, I'm going to have b squared times root 2 plus b, 2 plus root 2b minus root 2b minus b squared. Technically, you can skip the step. Everyone skips the step and just writes it as 2. Oops, I wrote the minus twice, but oh no, I didn't. Sorry, that minus is over there. Basically, the denominator, I'll just rewrite in the same step because I don't want to rewrite it. It's 2 minus a squared. You should know how to rationalize that immediately to that. I just showed the middle step here. Again, these two cancel out. So my denominator here is just 2 minus b squared. Now that we've rationalized this, what we can do is we can simplify this a bit further. So let's think about how to simplify all of this. I'm going to just start with the numerator. I am just going to expand that out and that out. Actually, I'm going to simplify the denominator first, because that's a lot easier to simplify. A squared and b squared have 2's over here, which will eventually cancel out with these 2's. So I'm just going to simplify the denominator first. I'll work with the numerator once I have the denominator completely simplified. So that's just going to be 2 plus root 3. That's my a squared from there. I'll do the same. Two minus root 3, just from my b squared over there. Now I'm going to simplify this. I'm going to distribute the negatives into the bracket and combine like terms in the same step. Again, this is a complex problem. That's why I'm skipping simple steps, but try to avoid silly mistakes. Normally in a test, I'd probably do all the steps because I sometimes am prone to these silly mistakes as well. But basically 2 minus 2 is 0. Then distributing the negative there makes it negative root 3. And over here, 2 minus 2 is a 0, and negative distributes that to make it positive root 3. Next, I'm just going to move this negative to the top, and that's going to give me a common denominator of a root 3. So I just have negative a squared times root 2 minus a plus b squared root 2 plus b over root 3. So now we've simplified this quite a bit. At least we've managed to rationalize the denominator. We've just got to do our substitution back and simplify a little bit further. So let's see, if I'm simplifying now, I think I can probably expand out the top over here. So if I expand out the top, I'll get negative root 2 a square plus a cube plus root 2b square plus b cube over root 3. Now, the reason why I did the expansion is because I don't want to sub in this thing back into here, because it's going to be a bit complicated if I subbed in that whole thing. So I actually turned it into this just to see if I can simplify it a bit further. We have a couple of a squares and b squares, which are pretty easy to replace because we know what those are. And a cubed plus b cubed. Okay, to simplify a cubed plus b cubed, we've got to do a difference or sum of cubes, I guess. Sum of cubes. I think that would probably be the best way to do it. So I'm going to write these two terms together, negative root 2a square plus root 2b square plus a cube plus b cube over root 3. And then what I'm going to do is I'm going to just common factor this out, root 2 a square plus b square. And this I'm going to sum of cubes it. Hopefully you know how to do sum of cubes. Again, I'm not going to explain that in this video. So this is the equation that I get over here. And now all I have to do is plug in everything into this equation, and that should give me my final solution. So a square and b square. I'm gonna grab another sheet as well to continue on. It's not gonna fit on this page. A square plus b square. That's just from my original step here at the top. I'm just going to plug in these two in over there. So root 2 plus root 3 plus 2 minus root 3. That's pretty easy to simplify. Plus a plus b. Okay, let's do a plus b next. So to do a plus b, I'm going to need a full sheet actually. So I'm going to rewrite this on paper. So, okay, I know that's really easy to do. I'm just going to do a plus b on this thing first, and then I'm going to plug it back into these formulas. Let's do a plus b. I know that from my original equation, that's what a is, and this is what b is. So to simplify a plus b, that's just a root of 2 plus root 3 plus root of 2 minus root 3. Can't really combine these, but what I can do is I can actually square both sides. So this side over here is going to give me a square plus ab plus b square. And this side is going to give me 2 plus root 3 root. So this is just 2 plus root 3 plus first term. Then the two middle terms multiplied by each other is going to give me 2 times root of 2 plus root 3 times root of 2 minus root 3. I'm just expanding using FOIL. And last term times last term is just 2 minus root 3. So that's the expansion of that, which is basically a plus b square. I'm just going to write it as a plus b square. I don't know why I expanded this side. I should only be expanding this side over here, technically. So over here, 2 plus 2 is just 4. Root 3 and negative root 3 cancel. And over here I have 2, and then I can multiply these two square roots by each other. So technically, if I'm multiplying a square root with a square root, I'm just multiplying the insides. So that's just going to turn into 2 times 2 is 4. Again, this is rationalizing, so the middle terms will cancel each other out. I'm not going to show it here. Actually, I will. Why not? So 4 minus 2 root 3 plus 2 root 3 minus 3, which is 4 plus 2 times root of, these two cancel, and 4 minus 3 is 1, which is just 4 plus 2, which is 6. So a plus b squared is just 6, which means a plus b equals root of 6. Okay, now that we got a plus b, which was needed in this equation over here, I just need to get ab. I know what a squared plus b squared already is. I did that really quickly last time, and I'll do it again as soon as I get that, but I just need to find AB at this point. So AB is just simply A times B. So let's do that over here. AB equals root of 2 plus root 3 times root of 2 minus root 3. So I'm just multiplying these two together. 2 times 2 is root 4 minus 2 root 3 plus 2 root 3 minus 3. These two cancel. That's just root of 1, which is 1. I think I found everything I pretty much need to sort back into my main equation over here. I think I can actually fit it over here. Try and squeeze it in this line. So root 2 is just the same. A squared plus b squared. Okay, I'll do that over here. I didn't show it. Kind of showed it a bit earlier. A squared plus b squared is just adding these two up, which is really simple. It's just 2 plus root 3 plus 2 minus root 3, which is just 4. So let's replace everything in this equation now. A squared plus b squared is 4. a plus b is root 6. And then a squared plus b squared, these two are just 4. And then ab is just 1, so minus 1. So this becomes 4 root 2 plus 3 root 6. Actually realized I made a tiny mistake here. I forgot the negative sign there. I thought that was an equals. Just gonna fix that really quick. So this last part here is a bit wrong. Negative, but it's not gonna take too long to fix. So that's a negative, which means this is gonna become a negative. Which means this inside here is not correct. And then this is all divided by root 3 as well. That root 3, I didn't include it because I didn't have space there, but I'll do it over here. So let me just fix this part here. So this is wrong as well. I'm actually doing a square minus b square, not plus. So a square minus b square. So 2 minus 2 is just 0. Root 3 minus negative root 3, that's 2 root 3. That's where the mistake is over here. This is just 2 root 3. And then this just becomes 2 root 6. So now I have, no wait, that's a negative. Don't forget that negative. Negative 2 root 6. So what I have at this point here, when I fix the mistake, is I have negative 2 root 6 plus 3 root 6 divided by root 3. Can combine like terms, so that's just root 6 over root 3. And then finally, I can divide these, and my final answer to this question will be root 2. And that is my fully simplified solution to this question. Definitely a complicated question, and if I didn't make that silly mistake of thinking that that negative sign was an equal to sign, I would not have made that silly mistake at the end over there. But hopefully this video made sense and you found it helpful. If you did, please hit that like and subscribe button. Thank you for watching and have a wonderful day.